Okay. All right. Hello. Aarush.
Hello.
How's it going?
Good. How are you?
I'm doing good. Because we're on a little bit of a time crunch today, we're just gonna get started right away. Right away.
Sure.
Hello everyone. I'm Neil Mittal, and this is Don't Blink. This is FTC Rookie Rescue, and today we're joined by Aarush Sharma. If you want to go ahead and introduce yourself.
I'm a graduate now, so I'm an undergraduate student at Yale. This is my third year. I'm studying computer science and economics. I was one of the founding members of Don't Blink. I was on the team for about 4 years, and I graduated during Fright Frenzy in 2022. And I've been mentoring, this team ever since. And while I was on the team, I started out as a programmer, but I eventually transitioned to also CADing and doing a lot of the mechanical work as well.
Yeah, sure. So I think we've met a lot of the other people in the Zoom, but if you guys want to introduce yourselves really quickly too. Vikram and Arnav.
Yeah, so I'm Vikram.
I'm Arnav, and I'm one of the co-captains on this team with Neil.
Yeah,
You've seen us before, so.
Yep.
I'm also a programmer, and Arnav is mechanical.
And
Hello, I'm Rishi. I'm a programmer at Link.
awesome. So I think we should first get started off with what everyone's wanting to hear. What are your opinions on this year's game, Aarush?
Yeah. So this is like the seventh game that I've kind of been a part of, like even indirectly as a mentor now. I will say this is like a pretty challenging game, especially at the highest levels. I heard a lot about the extension limits on this game. I think it's 20 by 42, and that's like a box, it's not like just from one point to one point. That's what I learned recently. So I think that coupled with, there's just like a lot of cycling and the specimen this year seems to be pretty tricky as well. I think this is a pretty hard game at the highest level. So it should be fun to see, complicated designs down the road that are able to do all these tasks like efficiently. I'm looking forward to seeing robots with those types of designs that can handle all these use cases.
Yeah, sure. Do you want to tell us a little bit more about your extension limit? What are your thoughts on like intake and outtake and how the points are distributed? What do you think the meta will be?
Yeah, I think that, in previous years we see robots that they're like adopting a strategy of kind of sitting in one place or like reducing movement overall. So, if you go back in FTC history, there are a bunch of robots that when they cycle, they would just, intake, and their intake would be fixed on their robot. So they would drive up to an element they want to intake, and then they would drive to a place they want to outtake to deposit. But, in recent years, we see people start to adopt, intake slides or, extension systems that go outside of the robot boundary to basically speed up these cycle times. And this year, the limit, I think, kind of makes it so that you can only extend, so much so that it's hard to make a robot that just sits in one place to cycle. So I think that's really interesting because it's kind of going away from like, I think what FTC was going towards, which is more like just sitting and cycling in one place. And when I first saw the game, I didn't read about the extension limits, so I thought, the best robot would probably be one that can intake all the way from, any area inside the middle zone that has all of those blocks and deposit wherever needed. And in auto, it would be able to intake off the wall with the specimen and deposit on the rungs while having like very reduced movements. But the extension limit makes it so that teams can only optimize in like, I think one direction, which is like interesting. So there's still an element of driving involved.
Yeah. Yeah, for sure. Now, I want to pivot a little bit towards what the main focus of this meeting was supposed to be, which is localization methods and maybe some of the pathing that is used in FTC for the rookie teams that are just getting started with this game, right? So,
Sure.
What are your thoughts on some of the localization methods that are out there regarding like
Mhm.
OTOS, Odo, and maybe video localization.
So I am a little bit out of the loop on OTOS, but what I've heard is that it's like an alternative to odometry. And maybe you guys can touch on it a bit more because I think you guys have used it a little bit and had some experience with testing around with that. But I think it's cool to see new localization methods come up. Traditionally teams I think use 2 or 3 wheel odometry. Our team specifically, we've always used 2 wheel because the IMUs kind of served us pretty well, and we just noticed in like prior years, at least during my time when we used to test, is 3 wheel just tends to have more drift over time, especially if you use the pods more. And they start to loosen up, or the springs start to become a bit more inconsistent. Whereas the IMU is pretty consistent overall as long as your hubs are good. So I don't think you can go wrong with odometry, especially since there's no terrain in this game, and there's not too much driving as well in terms of like going from one place to another. It's more like cycling. So odometry or 2 or 3 wheel odometry in that sense should be pretty good. And there are a bunch of different methods for teams that want to do localization that don't necessarily have access to wheel odometry or don't want to do it due to space constraints. I think one great alternative is distance sensors. I think Rishi mentioned to me a few days ago that his team used distance sensors in prior years. So maybe he can touch more upon that. But using that to localize is always an option, even if it's not to localize, but just to see how far you are from something and kind of base your autos on that. It's a lot better than time based or just kind of like guessing and checking what your auto should be doing. OpenCV is also another great alternative, or just Vision in general. There are a lot of markers on the field that you can use to localize your robot, and even if you're not using those marks, there are also a bunch of different things on the field that always stay the same, such as the rungs or just the center points in the field. And localizing to that is also a great option if you have like that software capability.
Yeah, for sure. Everyone else as well, like Rishi, Vikram, and Arnav, definitely feel free to touch on some of your ideas regarding localization. I know on our team, we were planning on maybe adding a distance sensor to the back of our robot so that we could localize with the submersible bar when going to hang our first specimen. I think we tried our best not to use I2C, and we try to maintain with our odometry so that we can keep our lag down and stuff like that. But it's always something to think about because there's lots of different ways to localize, and some will work better for different teams and some will work better for your team. So Aarush, I wanted to ask you about some of your ideas in terms of intaking this year and what you thought about the best way to do that was, and maybe after that we can get into a little bit more of your experience in FTC as a whole.
Yeah, sounds good. I think the intake is pretty complicated this game, and I think it's like one of the most overlooked subsystems on a robot. Even in prior years, I think people spend a lot of time thinking about their deposits and trying to optimize that. But intaking, as simple as it might sound, depending on the year, is definitely the hardest subsystem to tackle, and this year is no different. The samples are like a weird dimension, and they're not just a straight block. They have like weird divots in them as well. So claw designs and passive intake systems have to keep that in mind. And I think that's a great starting point, especially for rookie teams. If you make a claw that has kind of like a V indent in the middle to grab the samples, you can get like a good grasp, and it's just a great starting point to go in terms of consistency and ease of use. I think when you look at more advanced teams, especially at the higher level, you need to start thinking about multiple things. You have how fast you want to grab the samples, how easy is it to grab a specific sample out of like a group, and also how do you make sure that you're actually grabbing the right color and not picking up a sample of a different color or like a different team. And I think for that, whether or not you use an active or passive intake, just keeping that in mind is important. So for this, I would say for teams that are using, or by passive I mean non-active intakes, so like claws or like servo-actuated intakes. I'm using the wrong word, but I hope the idea gets across. So for those types of intakes, having like another degree of freedom that can, manipulate not only like the X direction of where you want to pick up from, but also maybe swivel to adjust the angle, or having a claw that the gripper can correct for any changes in angle. I think that's probably a really good way to go about having a servo actuated claw. And then for active intake teams, I think you can go multiple ways. In prior years, teams always had like a color distance sensor inside whatever hopper they have that stores whatever is being intook. So detecting that in terms of the color, and then you can spit it back out or eject it if it's the wrong color. I think that's also a great way to go about it. And then actually getting inside that area to intake, I think slides are definitely the move. I know a lot of teams are doing like big arms. The issue with that, in my opinion, is you would hit the rung or like the hanging bars. I don't know what they're called, but
chambers.
And generally that's like a lot of torque for. Yeah, that's generally just like a lot of torque for the whatever system is being actuated. So I would stick to slides. I think that's like a pretty safe way to kind of get in there and intake.
Yeah, I definitely agree. I think like long arms are good to some extent, but when they get too long, they obviously hit the chamber, and then like it's just kind of difficult to get to different positions while keeping your robot in the same position. So with slides,
right,
you can come back and have your robot stay in the same place, whereas with an arm that's rotated down, you kind of have to move your robot back and then adjust based on that. And that gets like a lot harder. So
yeah, for sure.
Yeah. So do you want to tell us a little bit more about why you would spit elements out during this game? Because I think rookie teams are not so well versed on that topic.
Yeah, sure. So, I mean, I think every year there's some sort of penalty if you possess an element of the wrong color. I'm pretty sure this game is no different, but do correct me if I'm wrong. I'm not like fully up to date on the manuals. So if you're grabbing an element of the wrong color, if it's a servo-actuated intake, it's very easy to kind of, just open the claw and drop whatever element you have. But if you're using something like an active intake with rollers or tubing, you have to make sure that you can spit the element back out. It's harder to do it with these kinds of systems because normally they're in an enclosure and it's kind of hard to see what you exactly are intaking. So for that reason, having a sensor that can detect the color and give feedback to the drivers either through telemetry or gamepad rumbles or lights on your robot that just tell you like what color is being intook, you can make like an appropriate action accordingly. Some teams I know have it fully automated, so if they intake something with the wrong color, no matter what, there's an automatic override that spits out the element.
And then my next question was about what your thoughts are on like intaking the specimen and the samples from the same intake, because like so many teams are taking those specimens from the wall rather than picking them up off the ground with their intake and then using their outtake to do that action. So like, what do you think about that? Is it faster? Is it slower?
Yeah, I can touch on that. I think teams that have an intake on their outtake, so a transferless design, where they're not, transferring the specimen or samples inside the robot. It's just like the same system being used to intake and outtake. I think those types of teams should be intaking from the ground instead of the wall, unless they have like a very good ball intake. And I think the reason why is because you can kind of make an enclosure that doesn't really fit the entirety of whatever is being intook. So in this case, a specimen, you can, or like a sample, you can let like a part of the sample hang outside your intake box. So if this is your box and this is the size of the sample and it's a little bigger than the actual enclosure that's holding the sample, you can intake something with the specimen on it, or you can intake a specimen and the clip part of it can just hang outside your intake. And you can design a system that appropriately, corrects it for how you want it to place. I think that way is good because you avoid adding like unnecessary complications in terms of like a new mechanism to load clips on. But also you can kind of cycle the same way. So if you're cycling, from the middle area or just like random samples on the field, the same way as you're cycling things that have like a specimen that has a clip on it, I think that makes your driving a lot more consistent. That makes your robot a lot more consistent. That's definitely a plus. And I think for teams that use a transfer system, like I think even before thinking about a clip bot, you should really make sure like your intake and outtake system in general is like perfect. Like it's good to go. It's fully tested. Because I think adding unnecessary complexities can really cause like inconsistencies, and we've seen this in prior years, not just with this game, but when I was in FTC, adding random things to make the robot better has definitely turned out to be not a great idea if it's not well tested and kind of well proved. So in that sense, I think teams that have like a really good intake and outtake system can consider adding on something that handles the clips. I think, like just off my head, ideas for that would be something that just grabs the clips into like a mag and maybe use a mechanism that actually loads on the clips. And I think I've seen the field a couple of times. I think from just like my testing, it's really hard to get the clips onto the samples. So, figuring out a way to properly manipulate the clips to actually attach to the samples is also something you should definitely consider if they're making that kind of an archetype.
Yeah, Clipbot is really interesting and honestly like going to be really difficult. I think someone in the Discord had posted about their design on a Clipbot and it was kind of interesting. And I'm really excited honestly to see like when more teams start posting about it, when more teams start releasing their designs. So I wanted to ask whether you think it's worth it for rookie teams to create something transferless or with the transfer, and then also maybe Clipbot. Like how much risk should rookie teams take when they're obviously rookies?
I think transfers are particularly hard to do as a rookie. And I think the reason why is because there's a lot of like precision needed in terms of transfer for any game, not just this game. And maybe you don't have that CAD experience that a lot of these veteran teams do, or you just simply aren't well versed in making transfers. Because I think personally it takes a lot of practice to nail down like how exactly transfer should work, what makes a good transfer, what makes a transfer effective, and not too complicated with a lot of steps. So I think in that sense, the transferless design is really good. I think teams should take inspiration from. There's a robotics team that I think a lot of archetypes can be modeled after, called A417. And their robotics team, they have a really cool robot, which just their intake is basically their outtake. It's just a pivoting side system that has an intake at the end of it. And it seems very simple, but they perform really well at Worlds and throughout most of their competitions. And we're very fast at cycling. So a lot of driver practice coupled with a transferless design, I think, can make a very, very good rookie robot. I think even if you look beyond the scope of just like your solo game, in competitions, I think a lot of the really, really good teams are going to prioritize making a robot that is either a clip robot or can do the specimen effectively. So they would want a robot that can couple them and do the deposit in the basket. So thinking about it from that perspective, where you're a supporting alliance partner and maybe not well versed in every aspect of the game, but really, really good at just cycling, I think that's also something rookie should definitely consider.
Yeah. Okay. I also wanted to ask you about your experience in FTC. So, so far, thank you so much for all your answers. They've been really insightful. But I wanted to hear about like some of your experience. What are some of your favorite things to do when it comes to maybe CADing or programming or designing things?
Yeah. I think CADing a lot is very important. A lot of people tend to stick to just one CAD document and kind of see it all the way through. When me and Ashwin used to CAD for our robots, way back when, it was always like multiple documents, lots of folders. We left like half our designs halfway through, fully incompleted, just because we didn't like one element. I think teams should shy away from seeing like something all the way through if they start working on something. Like I think it's a good thing to know like how to assess a prototype, whether it's in CAD or in person, and see how to move on from there. It's I think it's important just to like evaluate how good a prototype is, and if there are like specific like elements missing fundamentally that require you to change designs, and to be able to make that decision and say, okay, yeah, we're going to scrap this, we're going to move on, this is our new idea, and being able to do that is very important. So I think it's definitely like a high risk kind of mindset to have, where you're always scrapping or always improving on a design. But I think in the long run, it's definitely paid off for our team at least, because we go through like multiple iterations for not just individual subsystems, but full robot archetypes. Like we CAD out not just like a simple robot. We're trying to CAD like the most complicated robot all the way to the most simple robot that we think can do all the tasks, and then we choose effectively. So high volume CAD, I think, is something that's a good skill to have. What else? I think driver practice is very important. The balance between like how much on your robot is automated versus how much you're actually practicing with driving is very important. I think in recent years, especially, teams rely way too much on automation. There's always a risk of stuff not working, but even more than that, like there are times when just really, really good flow while driving is better. Like in Freight Frenzy, for example, our drive team had maybe one automation, which was the gamepads would rumble if we entered more than one element, or it would rumble if we had an element in our little box, and that was it. Like everything else was fully manual, and our driver and operator, we just practiced like from January to April, like our robot just was being iterated on, but we weren't really changing like the fundamental systems too much, because again, high volume CAD, we got our design like fully done by like late November, December. And that allowed us to really practice fully and not really necessarily rely on too many automations during the tele-up period. I think that's why our tele was like particularly good that year, because we really had everything on lock in terms of driving. And yeah, I think one last tip maybe is auto. From our power play season, you can go back and watch a lot of the videos, but you really should be prepared for all sorts of scenarios. It's a game, especially this year. It's like not a very straightforward autonomous period, because especially if you're picking from like the middle zone, being able to pick specific colors you want is going to be tricky. So and in general, like making sure your pathing is good, making sure you're at a high level. You're looking for if your robot gets bumped, if you get thrown off your path, if another robot hits you, or if you miss a cycle, what happens? Like taking into account those types of errors inside your programs is good. And even for rookies, like when you're starting out, making those steps, like, okay, we have like our preload done, we have one cycle done, now we have two cycles done. Eventually you get to a point where you're satisfied with your autonomous, then you start to basically run a bunch of tests with what happens if you get bumped, and that's what improves the consistency in the long run.
Yeah, and we've definitely veered off the topic of localization methods, but I just want to ask you a couple more questions regarding like how rookie teams should go about their season and how they should start off. So
I can tackle those questions. I just want to answer one or two questions in the chat really quickly.
Yeah.
About rebuilds, since it's on this topic. So the question is like, what do you guys think about rebuilds? When should it be done, and what's the process? When would you recommend teams do a rebuild? I think again, this is very like a personal thing. I think rebuilds are, depending on your team, either like it really depends on your team's risk appetite and your budget. So I think teams that don't have like a big budget or a lot of resources to allocate to a rebuild, you shouldn't necessarily be rebuilding your entire robot, but more so improving on specific mechanisms. And I think a good way to find success in FTC is to make sure your robot is modular, so that especially if you don't want to rebuild, it's really easy for you to switch out a subsystem for, something that's improved even slightly, and that makes sure that you don't have to change the entire robot from scratch. But for teams that do have the resources for rebuild, um, I think you will find a lot of times that you start to see new metas develop throughout the season. You start to see new, specific things inside the game that you find with your own testing or your own driving that you want changed on your robot. And when you can fundamentally change it with like a simple subsystem swap or, it's like a full new archetype for a robot, you realize that the highest level robot is, some robot that you just don't have right now, and it's impossible to build on your current base. I think that's when you can like say, okay, if our current robot's working fine and we have enough resources to allocate to a new robot, we can keep testing on our current robot while we build a new one. And I think that's what our team has done in the past. And the thing is, once you nail every single, aspect you want done in a rebuild, and you're 100% confident that you can package and you can fit and you can kind of have like all those elements down, then the rebuild is not complicated at all. So our World's Robot in Power Play, the robot that won, we built that in 2.5 weeks, probably, built and coded, because the code base was pretty much the same, because the robot archetype was like very similar. It was just we fixed so many small issues and kind of optimized it, to the highest level that we could before our competition, and that really allowed us to complete a rebuild in such a short time. And I mean, even then, it would have been nice if we had some more time for like auto tuning and testing. You could see like our World's qualification matches that year went pretty bad because we just ran into a lot of random issues that we wouldn't have if we didn't rebuild so late. So I think setting a clear timeline is also pretty important with the rebuild. But at the end, it worked out for us. And I think most seasons we end up doing a rebuild anyway. So that's just kind of how our team rolls. So it really, again, depends on your team specifically.
Yeah.
Yeah, there's another question on if you could redesign one of your robots, what would you make it modular? I would say most of our robots were modular, like in prior years. Our center stage robot specifically wasn't super modular because it was like very, very tightly packaged, and it had like a lot of like complicated subsystems on it, which I think you can see like our performance that year speaks for itself. Like we kind of overcomplicated the robot, and the team that won Clueless had like a very, very simple robot that was super consistent and very well driven, with a lot of like cool software and neat like fixes and stuff. So I think in that sense, our team can better evaluate how to choose like consistency over complexity. But it was like our new generation of FTC for our team. But all of our other robots in the past have definitely been modular. Like our power play robot had a lot of open space in the center, and we had a bunch of mounting holes that we can swap all the intake subsystem on. Like our let's see, the year before that was Freight Frenzy, right? Yeah, our Freight Frenzy robot also was pretty modular. Like our intake subsystem could come off in 8 screws. That's why, like by MTI, we had a full new intake, but the rest of the robots did the exact same. And something nice about our team is like we tend to run arms instead of slides, and that just makes everything like 10 times more modular because we can swap the arms out with just unscrewing our side plates and pulling the things off the main shaft, pulling the arms off the main shaft. So in that sense, our robots have always been like fairly modular.
I think we'll wrap it up with this last question in the chat. If you're rebuilding, isn't it more optimal to just rebuild everything?
No, definitely not. There's a lot of places where it's better to just optimize. So for example, in our Freight Frenzy season, it didn't make sense to rebuild the entire robot because our outtake system was really good. The only issues we had was like with our intake, and our intake had like some uh, issues with spacing that we just needed to fix. And since it was a modular robot, we were like, it was really easy for us to just space out our intake. Um, and even in other seasons, like there are elements of your robot that work perfectly fine, and it's just like a quick fix that really changes like the performance of one subsystem that it's better to do that than rebuild the entire robot and run into other consistency issues. I would also say like you should not rebuild early and mid season. You should like I think first unless your robot is like very far from what you want it at, because there are a lot of competitions at like a local or regional stage that are coming up that you can definitely win with like a optimized and well-driven robot that doesn't necessarily need to be at the highest level. I think rebuilds are also well suited for late stage in FTC, so worlds or invitationals.
Yeah. Yeah. There's one last question in the chat. We're kind of out of time, but do you want to quickly?
Yeah, I got it. Sure. So world-class team. I think, there's definitely an element of luck during a competition, like that I think goes unsaid in FTC a lot of times because a lot of people just tend to focus, robots, robots, robots. There's like your control hub's crashing or, like your vision pipeline just suddenly stops working. Like this has happened to our team a lot of times in the past, and like we've lost competitions because of it. Like an ultimate goal, we lost New Jersey States. Partly because our robot, wasn't as good as the people we competed at in New Jersey State finals, but it was also because like our autos just stopped working randomly, because somehow there was a duplicated vision file in our control hub that we still have no clue how it got there. So like outside of that element, if you can control like everything else, which is like just how consistent you can be, your strategy, like a lot of teams don't really pay attention to strategy. I would say like we didn't really have like the best power play robot, I would say. Like there were definitely better power play robots out there, but our strategy was like, very, very solid. Like in teleop, we made sure only to deposit on, the poles that we thought were gonna be like match swingers. That's what we called them. And in auto, we wanted position lock. Like we spent all of our time in auto. Like we didn't care about like the actual consistency of our cycles as long as we locked our position because that just means we win auto no matter what. So like focusing on that was like making these types of decisions, I think is what like kind of segregates like a very high level team from a team that can win worlds. But it's also very impressive. To be a world-class team is, I think, different. I think for that, you need to, make those decisions consistently year after year. And that requires like, really good training on like the internals of your team. So making sure your rookies are like really, really well versed with how your team handles things, making sure they're well trained, that they're at the same level by the time you graduate. Like I think that's something that our team could have done a bit better. Like especially in our last season, like we focused on our robots so much that we didn't train our rookies as well. But this past like in center stage, we like me and Ashmed, we helped them through a lot. And this year, hopefully, our team is going to perform a lot better. So yeah.
Nah, it's messed up.
What do you think of DR4B versus slides? I think this is a pivot slides game. I will say that. I don't think DR4B is always good early season because it's easy to use. Sorry, I have to answer that question. It's Mason's question. Okay. Yeah.
Okay.
I have to leave, but
yeah.
cool.
All right. Well, thank you so much for joining us, Aarush. It's always awesome to have you. But thank you everyone
for sure.
Thank you everyone for tuning in. This is FTC Rookie Rescue and Don't Blink signing off. We'll see you next Sunday at 6 p.m. for the next topic. Thank you, everyone.
Good luck, everyone.
Bye.